Hello guys, now we are going to see about deep learning. We know that deep learning is the subtopic of the machine learning. The deep learning is a popular one now implemented in every AI platform. Deep learning is a type of machine learning that use artificial neural network to learn from data. It is a subset of machine learning that use multi-layer to progressively extract higher level features from the raw input. Okay, the deep learning will use in all the places, more or less now. In image processing, lower layer may identify the edges, while higher layer may identify the concept relevant to this human such as digits or letters. Deep learning is created inspired by the human brain. If we take a human brain, it's made up of billions of neurons and interconnected with complex network. So each neuron receive input from other neurons and send its own output to the other neurons. So when the human is born, he don't know anything, but the information is gathered, stored in the net brain. Then whenever you see, so it will the like neurons will be activated and and select what is this, what information was stored. Based on that, it will give the result. Same like that, the deep learning is working. So the first layer of network receive the raw input data. The output layer is a prediction classification of the data. So the deep line is the input layer, neural network, hidden layer, and output layer. The hidden layer will calculate and work what the decision need to take. Then it will give the output. So deep learning is used in various of tasks like image recognition, natural language processing, speech recognition, machine translation, medical diagnosis, financial trading, and self-driving car. So in the self-driving car, it automatically get the information based on the previous loaded data and work itself. So here this is the deep learning concept. When you insert some image, this is the input layer. This is a neural network. This is a node, and this is the output layer. Based on the calculation and decision by the neurons, it give the result board. It will give like 0.95 percentage. This is some percent. So the biggest percent is the predicted one. So how this neuron is working? If we see here down, is a input layer. In the input layer, we have the nodes like this. This is the node x1, x2, x3. Then each nodes will say we have the weight w1, w2, w3. Then it will make summarization, and when it's summarization, it add with the bias. If you don't add the bias, it may be possible become zero. So in the neural network, conversion neural network also we are using here. The network value must not be zero, so we add the bias here and send here the activation function gives the result as prediction value, prediction output. Then the activation function may be ReLU, Sigmoid, Softmax. These are all used here. Based on the soft, when you use Softmax here, it will give the classification prediction. Yes or no, positive, negative, bird or dog, like that. So when it's give outputs y prediction, if it's have error, then again back propagation, change the weight, do the bias with summarization and activation function, then give the correct prediction. So this is the short form. This is the x input layer. Then weight, this weight. Then if you calculate x into w, it will add with bias plus b. Then it will give the output. It will do the calculation like this. If it's error happen, it will go back again and calculate and give the result. So the neural network are the functions of deep learning. They are inspired by the human brain, I said, which is made up of billions of neurons. In the neural network, each layers of network is set of interconnected neurons. The first layer of the network receive raw input, and the output layer, last layer, is prediction or classification of the data. So it have the number of layers in network is called the depth of the network. Deep neural network has many layers, which allow them to learn more complex pattern in the data. So this is the hinder layers. It based on this depth, it will calculate the complex predictions. The neural network are trained using a process called backpropagation. Backpropagation is a way of calculating the error in the neural network prediction, then using that error to update the weight of the network connection. The process is repeated many times until the network predictions are accurate. So it will go the input layer, then create a network and give the result. If this prediction will be wrong, then again go to back propagation, change the weight, again come to the tab with bias and for activation function, then give the result. This will be continuous until it will give the correct prediction. So here the input layer, we know the input layer will be the raw data with the pixel of images. Then it will go to the convolution layer, or the core of the CNN. They are responsible for extracting feature from the input data. Each convolution layer has a set of filters. Okay, here each of a convolution layer has a set of filters, which are 2D matrix or 3D matrix used for scanning. Here in the convolution layer, we have the pooling. So based on the pooling layer, it reduces the size of the features. This is done to reduce the number of parameters in the network to make the network more efficient. So based if you put the scaling in the pooling, it will reduce the size of the network and make the network efficient. The two main type of pooling layers are max pooling and average pooling. Max pooling take the minimum value from the each region of the future map, while average pooling takes the average values. So fully connected layers are the final layer of the CNN. They are responsible for making the final prediction. The component used in the CNNs are, as I said, the activation function, regularization, and dropout. Activation function used to introduce non-linear in the network. So this is important because it allows the network to learn more complex pattern in the data. Okay, the regularization is used to prevent the network from overfitting the training data. So we know the L1 regularization, L2 regularization. It will avoid the overfitting data. And also, dropout is a technique that is used to prevent the network from relying too heavily on any particular features. This is done by randomly drop out some of the neuron in the neural during data. So dropouts also help to randomly drop off some layer in the neuron. It will give the accurate for accurate prediction. So we have many type of CN architecture here: AlexNet, VGGNet, CNN, RESTNet. AlexNet was the first CNN to achieve state-of-the-art result of the ImageNet large-scale visual recognition challenge. So it has 8 convolution layer and 3 fully connected layer. VVGNet is a CNN that is designed to more efficient than previous AlexNet. It has 16 conversion layer Alexa have only 8 convolution layer, but it has 16 convolution layer and 3 fully connected layer. The next one is RESTnet. RESTnet is the CNN that designed to address the problem of the vanishing gradient. It is a restitution connection architecture which allows the network to learn long-range dependencies. So these are the research based on the research. They bring the researcher, give the architecture. If you follow the structure same like this and create the model using TensorFlow, we will get the good model to predict and used in the prediction for use in the all the fields and areas. So this is the like this format we can create the deep learning using TensorFlow. Here we will create the a conversion layer. Then we will get the model and use for the prediction. Okay, thank you.